All right, problem number 30 in group theory. Find the order of GL2FP, which is the 2 by 2 invertible matrices over FP, the field sub P, mod P. Okay, so we know that, let's see, we have GL2F sub P are the invertible 2 by 2, let's do it like this, 2 by 2 matrices over FP. Okay, and we want to know how many possible ones are there. Well, such a matrix is invertible if and only if the column, let's say, ordered pairs of columns are linearly independent over FP squared. Okay. And we have 2 by 2 matrices, so we have 2 columns. For the first column, there are p squared choices. There are p squared choices. However, we want to remove the 0 vector. So there are p squared minus 1 choices for the first column, because there are p squared elements in fp squared. Okay. And we're going to let v be the non-zero vector representing the first column. Okay. And we want a linearly independent second column, essentially. So the second, okay, I'll say such, so a vector that is linearly dependent, so not independent, but a vector that is linearly dependent to V are the scalar multiples, and we can represent this like 0v, 1v, dots, and so on, up to p minus 1v. Scalar multiples, maybe I'll say scalar multiples of v. Okay. Hence, there are p squared minus, let's see, we have p squared minus, there are p possible scalar multiples, so we want to remove all of those from the choices of the second column. Hence, there are p squared minus p possible choices for the second column. Okay, now probability. Therefore, we just multiply the possible choices for the first column by the possible choices for the second column. So the order of GL2 F sub P is equal to, we have p squared minus 1 times p squared minus p, where p squared minus 1 is, well, the possible elements of fp squared without the 0 vector for the first column, and the second column is, well, it's every possible element from fp squared, but we remove the linearly dependent vectors, which there are only p possible scalar multiples of the first column, and we get this order.